Okay, so my lecture did not go as planned on Friday due to various technical difficulties, and I promised you I would try to make it up to you with a recording. So this is my effort to do that. What I have put together for you is a little website here, CSC1351 CCT LSU EDU. This is the same server that you use to verify your final projects, but I put a page on there called regex.php. And what that page does is it allows you to easily play with regular expressions. The page looks like this. Now, this engine isn't written in Java, it's written in a language called PHP, but regular expressions are fairly universal in the way that they work across many different languages. So the way this is set up, we put a pattern in the first slot, and then we put three pieces of text, and the match is done 3 times. And the system shows you how each matches. So I have a bunch of example regular expressions and pieces of text, which I've thrown together here. Let's start with the first one called simple. So this just matches the pattern ABC. Now, letters and numbers automatically just match themselves. And the backslash in front of any shifted character like plus, minus, at, whatever like that also matches itself. But a backslash of a letter or a non-backslash of a special character might do something special, depending on how well you understand regular expressions. So what does this match do? It's going to find ABC in each of these strings, right? It's all this is telling you is that it found it, and this is what the match looked like. So there's not much to understand here. So let's go on to simple 2. Now in simple 2, what I've changed is I put the B in parentheses. As you recall, parentheses means group, and so there's a special capture that happens. And this is how that looks when the match occurs. So group 0 is always the entire match. Group 1 is the first grouping, and there is only one grouping, so that's what it shows us here. So again, this is very simple, and there's not a whole lot to say about it. It matches ABC, and it pulls out the B as a separate thing. Here's simple 3. Now, simple 3 takes a step. It uses these square brackets to give you a list of characters it can match. So the square bracket with X, Y, B inside matches X, a Y, or a B. And likewise, C, D, E, F matches a C, a D, an E, or an F. But because C, D, E, F is a range of characters, you can alternatively write that as C-F. And the hyphen in the middle says it's all the characters in between. If you want the hyphen to literally match itself, the easiest way is to make it the first or the last thing in the square bracket grouping. And now when I match this, in the first one, ABC matches A, B, C, and B. Well, okay, so they all still do the same things because these things are all similar letters. But I could have put, let's say I could have put an X here, and I could put a E here. And now I should be able to run it. And you can see that where I've got the X here, the X is the middle character, so that gets pulled into group 1. And then the last one I matched ABE because I've allowed the last character to be an E. So hopefully that all makes sense to you. Again, this is one of the simple things. So let's take simple 4. Now the difference with simple 4 is I put a caret at the start of the square bracket grouping. And what that does is it negates it. So this means any character that is not an X, Y, or B. So when I do the match, the middle character can't be an X, Y, or B. And in this, I put a Q, a P, and an R. So those all work, and those all get pulled out. All right, so that shows you some of the basic ways these patterns work. Let's look at how to match an integer. You might recall from class that \D is the same as square bracket 0-9 close square bracket. In other words, it matches a digit. And so when that happens, when I go to do this match, is it matches the 1 in every case, right? Because the value is 1, the value is 10, the value is minus 10. And if I'm matching an integer, that's probably not what I had in mind. What I had in mind, let's try again. Let's go to integer 2. So here I put \d star. Now you may recall that the star matches 0 or more of something. And so you would expect that \d star would match the 1, the 10, and maybe the 10 here. But it doesn't. In each case, it matches an empty string. And the reason is because I have a star, and star is allowed to match 0 things. Then it matches the empty string at the start of each of these strings instead of what I wanted. The way to fix that is to match \d plus. The plus matches 1 or more things, so it has to look for at least 1 integer that way. So let's try that. Okay, now when we do the match, we get 1, 10, and 10. And that's pretty good. That's kind of what we wanted. Except, of course, in this last example, I had the value is minus 10, and I'm not capturing the minus sign because minus obviously is not a digit. So the way I can fix that is I can change the pattern. I can put a minus question mark in the front. And you may recall that a question mark means matches 0 or 1 time. So I have 0 or 1 question marks in 1 or more digits, and that gives me an integer. And when I do the match, I get 1, 10, and minus 10. And it finally works the way I hoped it would. All right, let's move on. Matching fruit. So here I can match apple, pear, orange, or banana. And then I have 3 pieces of text, and I ask for the match. And it works in every case except the last case. Why didn't it match apple? Right? I said apples are yummy. That was a sentence, and apple is in my list of fruit. Well, you may have noticed that the A is capital here and lowercase there. And the regular expression is by default case sensitive. So let's try fruit 2. In fruit 2, what I've done is I've changed the first letter of each word to have a square bracket that includes the upper and the lower case value of the letter. By doing that, I allow for any of these words to appear at the beginning of a sentence. And so when I do the match this time, I get apple at the end. So that looks pretty good. Let's take a look at the last one. Now, the thing I've changed in the last one is I put a plus at the end. Now, remember I said that plus means 1 or more of the preceding thing. In this case, the preceding thing is the entire group, which can match any of these fruits. So when I do the match, the first one matched pear and banana, like always. But the last one, I have apple, pear, bananas are yummy. And so group 0 is going to match apple, pear, banana. Okay, because it can match any of these things, and it matches one after the other. And group 1 gets filled in with the last thing that it matched. So group 1 is just a single fruit, and the last fruit that it matched was banana. So that's what it shows. Okay, so you can put these groupings and these square brackets and these multiple match things together in different ways to create arbitrarily complex patterns. And once you get used to the syntax, regular expressions allow you to easily pull out, bits of text in large files that you might be working with. They're one of the great things in programming, I think, one of the great tools in programming. So now let's look at another example we talked about in a previous class, matching a phone number. So in this case, a phone number looks like 3 digits, a hyphen, and then 4 digits. And then I have a bunch of phone numbers listed. And in each case, it pulls out the phone number. But you notice that in the second example, I have an area code. And in the third example, I have a country code and an area code. And my pattern as it is doesn't pull out either of those things. So let's look at phone 2. In phone 2, I put an opening of a group, then a backslash paren, which matches a literal parentheses, then 3 digits, then a backslash close paren, which matches a literal close parentheses, then a backslash S. Backslash S, remember, is a white space character. So that's a space, a tab, a new line, or a carriage return, or forward feed, anything that you can't see. Excuse me. Anything that you can't see. And then I put at the closing of the, and then I put a closing group, the closing parentheses for the closing of the group, and then I put a question mark. And that means 0 or 1 of the preceding thing. I just paused it. Yeah, it's okay. I was going to buy tapes for us. Yeah, well, that's his money. He can do it. I don't. I don't have anything else. What? I'm not on the phone. I'm recording a lecture. It's cool, Ma. Ugh. Okay, so the thing I've just described you, this whole piece here, is going to optionally match a parentheses with 3 numbers in it and some white space afterward. I mean, 0 or more white space. So it doesn't have to have any white space. But if there is any, it won't prevent the match is the idea. And so now I get pattern matched with the area code pulled out, pattern matched with the area pulled out. So this is good. It takes us one step closer, right? We get the area code and the phone number, but it doesn't give us the country code. So let's try one more time. And now what I've done is inside the first group, I add another group. And inside this other group, I have a plus, a digit, a white space star, and then I put that in a question mark. I put that inside this first group. So this won't, that means the pattern can't match a country code without also matching an area code. So if I had a +1, 555, 1212, it wouldn't pick up the +1. So when I do the match, right, I can now get the country code. So this pattern, once you at first it looks quite complicated, but once you get used to it, that's a fairly straightforward way of parsing out a complete phone number from a piece of text. All right, that's it for phone numbers. Let's match a name. Shoot, I had more examples for that. Well, I may update these. I may update these more offline. But here's a name matching pattern. So what it's going to do is it's going to have 3 groups. And in the first group, we're going to have a square bracket A to Z capital, right? So that's going to match a capital letter. And then I'm going to have a lowercase A to Z plus. So that's going to be one or more lowercase letters. And then a closing of the first group. And then I'll have one or more spaces, and then a capital letter followed by a backslash dot. Backslash dot is going to match a literal period, and then one or more spaces. And that whole group gets a question mark, okay? Because this is an optional middle initial. And then this last pattern with a capital letter followed by one or more lowercase letters is the same as the first one. When I do the match, you can see that it's pulling out all the pieces that I want. I get the first name. In group 3, I get the middle initial. And in group 4, I get the last name. So it finds a name for me, something that matches the pattern of a name. And then it tells me, allows me to easily extract the first name, the middle initial, or the last name. And you can make this, this name thing more complex if you want. Okay, let's look at dates. This is, again, something that we talked about in class, right? So we can match a date and of the month, date, YYY format. And this is pretty simple. It's kind of like where we started with the phone number. So it's \D, hyphen, \D, hyphen, and then 4 \Ds. And then I can have a number of dates and it can match. But if you look at this, right, only the first one is really a date. These other things really aren't. And, chances are, if this is like a web form, if it's not 1900 or 2000, it isn't valid. So I probably should make use of that in the pattern, and I can do that. Let's look at date 2. So in date 2, instead of having 4 \Ds, I have open parentheses 19, pipe symbol 20, close parentheses. So that can match a 19 or a 20. So now this will only match if I've got a 19 or a 20 in the beginning. So this one will match and this one will match. But the last one, of course, is no good because there is no year 99, right? And there's no day of the month that's 47. And I could use those pieces of information as well if I wanted. And so if I want to make this more complicated and more accurate, I can do that. So in the first spot, instead of \D, I have 2 options. I have a 0 followed by a \D. So a 0 followed by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But if I have a 1, only a 0, 1, or 2 are valid. So I have those 2 choices in a group. And for the second thing, for the month, if I have a 0 or a 2 as my first digit, then I can have a 0 through 9 as my second digit. But if I have a 3, only a 0 or a 1 are valid, right? And so now when I do this match, I'm only going to match on the first one because the other 2 aren't really dates. And the pattern figures that out. I hope this is all making sense to you in the absence of questions to be asked. So this somehow didn't show up. We're going to have to fix this one. I have a very clever regular expression for finding primes, which I meant to show you. And I thought this was on the page. I will update it to make sure it gets there later. And I'll talk about it in class. Okay, so parentheses. So we can always, one of the easiest ways to match a parentheses would be to put a \, parentheses, a dot star, and a close, and a \, close parentheses. And so the \, open parentheses matches a literal parentheses. A dot matches any character except a new line. A star is 0 or more of the preceding thing. So any character that's not any number of characters that aren't a new line, and then a close parentheses. And so when I apply this to these pieces of text, right, I get the ABC from the function ABC, and I get index, and I get the parentheses X and close parentheses, which is probably not what I wanted, right? I probably wanted to see a balanced set of parentheses, so I probably didn't want that last one. And likewise with this final one, I got an open parentheses, a bunch of things, and a closed parentheses. And I probably just wanted the balanced ones, that is starting from the C and going to the D. So let's see how we can make that work better. I didn't put it there. This page does not have all the examples I thought I made. What I'm going to do is, instead of a dot, I'm going to match. I'm going to put an open square bracket, a caret, and then and an open and closed parentheses. So now I will match any character. Instead of any character that isn't a new line, I'm matching any character that isn't a parentheses. And now when I run the match, it does what I expected, right? It has the ABC, the X, and the CD. It has the balanced parentheses with no extra parentheses on either side. Hope that makes sense. And here's a final example, a quoted string. And in my quoted string, I have, what I've done is I've put a quote, an open parentheses to capture a group, an open square bracket, a caret, a quote, and a closed square bracket, and then a star. So inside the parentheses, I've got a group, and inside that group, I've got a square bracket, and I'm using it to match any number of characters that aren't a quote. So like in this case, it should match on the star 2. And it does, right? So my pattern matches on the star 2 with the quotes, and the group inside it matches without the quotes. But you find something goes kind of wrong with the other 2 pieces of text, because what I did was I embedded a backslash quote on the inside of the string. And my pattern isn't smart enough to understand that a backslash quote is a literal character and not the end of a quoted string. So how can we fix this? This turns out to be a little more complex. What you have to do is let me expand the characters on this thing, make the screen a little larger. So what I have is a group, and inside the group I have 2 things. I have a backslash parentheses, a backslash quote, a backslash followed by a quote, or a caret followed by a quote, and that's inside the parentheses. Now, there's something weird that happened with the formatting here, because I want to match a literal slash, and that should require 2 slashes here. And I don't understand why I'm only seeing 1, but just imagine that it looks like this. I'm just going to put this in, and hopefully this will still work the way I think it will. And so we got star 2, and then we got star 2 with this quote inside it. And then finally we get this other thing. So this works exactly the way you would expect it to work, right? So I've got a literal backslash followed by a quote, or a character that isn't a quote, and I have 0 or more of that choice of 2 things, right? So that's how we can match a literal string. Now I'm going to pause here, and I'm going to put back my my finding primes, and I'm just going to update a few things. Just a second.
Do you want the one? Do you want the cane sauce? I mean the cognac with the slaw.
Yeah, just the standard cognac. Your mother and I split it.
And any drinks?
I don't need a drink now, but your mother might want a tea. You can ask her.
Okay. Okay. Thank you.
Okay. I have just updated, found the little bugs in my code. So let's go back and look at name 2. So remember we had we were matching a name before, and we had an uppercase and a lower uppercase letter followed by lowercase letters. Well, now I've added a hyphen and a dash to things that can be in my name. And I did that with the first and last name. And then I put in here some other possibilities for names. And if I do the match, then I get the following things. Now you notice the first one didn't work out right because I said Kufang, but I didn't allow for the possibility of 2 uppercase letters. So if I put this to an F, then it should match, right? So then I can get the Kufang P Jakar, and Lavender Z mincemeat works. And then this one will match Anne Marie easily. So the idea here is I just added, 2 alternate characters here, but you can see, I think if you try to match people's names, enough weird things go on with people's names that you can tie your brain in knots trying to match them all. Still, sometimes a thing that mostly works is better than nothing. The other thing I wanted to show you is finding primes. So this is a really screwy example, and I see that my page didn't format the way I thought it would. There's another thing I have to fix. But in any event, the idea here, and this is something very clever someone came up with, this is going to match, this is a regular expression that's going to identify prime numbers. Look at that. Isn't it beautiful? So a caret, if it's not inside square brackets like that, a caret means the beginning of a string. And a dollar sign, when it's just by itself like that, means the end of a string. So this is forcing, this whole pattern has to match from the beginning to the end of the string, is what this caret at the beginning and dollar sign at the end means. Now, there is an implicit group for group 0, so I can put, so that's what this pipe symbol is working on. I guess for clarity, I could put this here, right? So the idea is I have 2 possibilities for my match. One is that I match a 1, an empty string or a 1. Hold on, not there, there. I match an empty string or a 1. And the other, well, I could, this is unnecessary. I can do it this way. Hold on. Editing this for you in real time. Okay, so it has to begin with a caret and end with a dollar sign. And in the middle, I've got a group, and that group has 2 choices. I can have either an empty string or a 1, or I can have 2 or more 1s. And ignore this. Let's take this question mark out. I mean, that's a more advanced feature than I meant to show you. All right, so I've changed it around as you watched it, and I'll update the code to reflect this. Anyway, I have, so the possibilities, I have an empty string or a 1, 2 or more 1s is what this second group is going to be. 2 or more 1s, and then \1 is going to match whichever in group 1. And That's now 2. Okay, I think I fixed this. I think I've made this better. So a \1 would be whatever's in group 1, and group 1 in this case is this whole thing. But a \2 would match whatever's in group 2, and that would be this whole thing. That's the second group. So if I can match 2 or more 1s, any number at least one time after matching this, then the match will be a success. And what this does is it either matches, it attempts to match a sequence of 1s. And if the length of the sequence of 1s is a prime number, then it won't match. And if it isn't a prime number, it will match. So I do the match, and we find that the 5 1s don't match, the 6 1s do, and 7 1s do not. And just to understand this a little better, right? So the way this has to match is I'm going to have to first thing I have to find is a sequence of 2 or more 1s. And in this case, right, I could do a 2, and if I find 2 of those, then it has to be followed by other pairs of 2s until the end of string. So that can't happen, right? I can find the first one, I can find the second one, but then there's only a single 1, and that can't match the 2 1s, so it doesn't work. So the pattern matcher can try 3 1s, but it can't match a second set of 3 1s because there just isn't one. So that fails. This one, on the other hand, first attempts to match the 2 1s, and then it's able to do that 2 more times and then come to the end of the string, so it succeeds. And the last one, we attempt 2 1s, but we can do this 2 more times, but then we're left with a leftover 1, so that can't match. And then we can try 3 1s, and we can match another 1 and a partial 1, but that doesn't get us all the way, so that fails. And then we can try 4, but then we can't even get another 1. So in this case, with 7, we aren't able to get a match. And that's how you can use a regular expression, this weird regular expression that you see on the screen before you, to match a prime number. And if you can understand this primes thing, then you're well on your way to regex wizardry. But I'm just showing you this prime number matcher for your because I think it's cool and interesting. I'm not going to ask you questions on that particular thing. So with that, I would like to conclude my little lecture on regular expressions and how you can play with them with this matcher that I've written for you. And I hope you will take advantage of it and teach yourself how to use regular expressions better. Hopefully see you in class on Monday. See ya.